Good day, I am Enzo Zasta, and with me are Franz Anido and Jermaine Ocampo, and we are here today to discuss how we answered problem set 7. So for the first part, part C, we are tasked to find the net present value of each project. As mentioned in the given, we utilize the NPV function to find the net present value of the cash flows from year 1 to 4, the final year, and added the value of year 0 to the result. Utilizing the same WACC of 10% for both, we calculated an NPV of 18.78 for project L and 19.98 for project S. So, moving on to part D, you're tasked to find the internal rate of return of each project. Similar to the previous segment, we utilized the IRR function to find the internal rate of return of the cash flows from year 0 to 4. With that, we calculated an IRR of 18.1% for project L and 23.6% for project S.
Moving on to part E, so we were tasked to draw the NPV profiles for both projects, and we were asked to compute for the discount rate of uh, the discount rate in which both profiles cross. So first, the NPV profiles were calculated by adding the cash flow from year 0 to the derived NPV using the WACC and the cash flows from years 1 to 3. As we can see in the graph, the lines for projects L and S intersect at a point between 5% and 10%. However, we are not fully sure as to the specific point in which both projects intersect. So computing for the cash flow difference per year of computing for the cash flow difference per year, we do this by subtracting the cash flows of project S per year to the cash flows of project L per year, and thus we get the values that you can see in the table. And computing for the IRR using these values, we get an IRR or a crossover rate of 8.68%. So going back to the graph earlier, we can see that the intersection point is somewhere around 8.68% as well. For part G, to compute for the modified internal rate of return or MIRRs of each project, we simply use the Excel function of MIRR, the sum of cash flows per project, and the given WACC of 10%. So we do this for both projects, which is why um we take the sum of cash flows for project L, and we use the WACC of 10%. And similarly for project S, we take the sum of cash flows for project S and we use the WACC of 10%.
For part H, we were asked to find the paybacks for project LNS. In doing so, we have to compute for the cumulative cash flows for the years given, so 0, 3. And as we can see in year 0, we have a negative 100 cash flow, but then added 10 and then 60 and then 80 in the succeeding years, which gives us a cumulative cash flow of 50 at the end of year 3. And in order to compute for the payback for the we have to identify which year the cumulative cash flows became positive and the year before that. We then add the year before the positive cumulative cash flow with the quotient of the cumulative cash flow for the negative year, and the cumulative cash flow of the year it became positive. So for simplicity, for the project L, we used the year 2, since that's where year 3 is the year where the cumulative cash flow became positive, and year 2 was the previous year when it was still negative. And so we added the year and then used the quotient of the negative value of the cumulative cash flow for year 2 divided by the cumulative cash flow for year 3. And that was the same method used for computing project S. And so we got a payback of 2.4 for project L, and then a payback of 1.6 for project S. Now, for part I, we were asked to compute the NPV, the IRR, and the MIRR of project P. So, using the given below, we use the NPV function of Excel to compute the net present value of the cash flows. So, in order to do this, we use the WACC of 10% as the discount rate, and the years 1 and 2 as the year where we compute the net present value. and then added the present value of year zero at negative 0.8 in millions of dollars, which gives us an NPV of 386,776.86 cents. So that's the value in thousands of pesos, or zero point 0.3 in millions of dollars. And lastly, we computed the IRR using the cash flows here, using the Excel function IRR, and we computed an IRR of 25%. And we used for the MIRR, we used the same values for the cash flows for project P, and used the 10% WACC for the refinancing rate and reinvestment return rate. Next, we were asked to find the IRR with a guess of 300,000. Thus, we computed the IRR again using the Excel formula, using the cash flows that were given, and the guess of 300,000, which gives us an IRR of 400,000. Now, for part two of that, we were asked to draw project piece and PV profile, and asked whether the cash flows were normal or non-normal, and should the project be accepted. So we concluded that project P is non-normal because the IRRs of 0 to 20%, as you can see here, are negative. And again, a negative in from the IRRs 410% to 500%. It became negative as well. So generally, we accept projects that have an IRR greater than its WACC. So in this case, we computed again 25% and 400% with a guess. But since the NPVs of some of the IRRs are negative, it would be wiser not to accept the projects because of the risks involved. So that concludes the discussion on problem set 7. Thank you very much.